gives me very great pleasure to have the opportunity to chair the next two of our papers. The first by Dr. Patrick Jolicoeur, who is coming to us from Toronto. It's a real pleasure, a genuine pleasure, I have to say, to introduce Patrick to this audience again. He received his doctorate from the University of Glasgow in 2019. And I'm very proud to say it was under my supervision. I had worked with Patrick both in his master's years in Glasgow and also for his PhD. During the course of his PhD, he was awarded a prestigious Wenner-Gren Award for fieldwork in the high Arctic of Canada. I think it's an indication of the value of his research into the interactions between peoples in Arctic Canada and Greenland in that case, which allowed him to be awarded that grant. His research had focused on the metal use and exchange of an indigenous Arctic group called the Dorset, and what this meant for the various inter- and intracultural encounters they had in the region around the start of the second millennium AD. He has since published an article about this research in American Antiquity, which of course was peer-reviewed and well received. And currently he is a Western Family postdoctoral fellow at the University of Toronto, where he's researching the debated Dorset-Inuit contact in Northern Labrador. The title of his paper today is Peoples of the Polar Sea, Encounters and Exchange in the Eastern North American Arctic at the start of the second millennium AD. So Patrick, we look forward to hear what you have to say, and good morning to you.
Yeah, good afternoon to everybody in the UK, and thanks for the introduction, and thanks also to the organizers for organizing this conference and the other speakers. Really interesting papers so far. So I'll just share screen and hopefully nothing explodes. Okay, so in my paper today, I'll be talking about the different types of human interactions that happened in the Eastern North American Arctic at the start of the second millennium. But before I get into that, a common theme about the paper so far has been the North and perceptions of the North and perceptions of the Arctic. And I think that's a really relevant discussion, even when we go a little bit further back in time. And that's because when most people think of the Arctic, our view is always skewed, especially if we're not indigenous Arctic people. And that's because when we think of the Arctic, we think of maps, and the Arctic's either really big or really small, or cut off at the top margin, or not even in the central focus of the map. So before I get into the meat and bones or meat and potatoes of what I'll be talking about, I'll just show a picture of the outline of the North American Arctic, so that's Canada and Greenland, over top of a projection of Europe, and they've been all corrected, so it's all the same true sizes and everything. You can just see how vast this area is. So, and that's part of the challenges of doing archaeology in this region, but it's also one of the interesting aspects about just how large the area is. So just keep this in mind as I talk about the topic today, or my discussion today, just in terms of how large of an area we're talking about. And I'll also show this chart. This is basically the culture history of the Arctic. So the human history of the Arctic since its first peopling about 5,000 years ago. And you're not supposed to memorize all the names. There's no quiz, don't worry. But the point of this chart is to show just how complex that human history is. Lots of different people, the timings of them coming into the Arctic, leaving the Arctic, etc., is incredibly complex and challenging, and they all have different names, and each region, which is represented by each column on the chart, has a different sort of naming tradition sometimes for very similar peoples. So the point of this is just to show how complex it is. The time period that I'll be focusing on today is right around AD 1000, so the start of the second millennium. And you can see there in the chart, there's basically three main groups that I'll be talking about. The late Dorset, who are kind of this last permutation of the first peoples to enter the Arctic. So they're the direct descendants of the first people that lived in the Arctic. And they kind of disappear around the 13th and 14th century. And there's still no solid answer about why the Dorset effectively stop existing. And genetic studies have shown that there are no descendants of those peoples in indigenous Arctic people today who are descendant from the Inuit or who are Inuit. And the other group that you'll notice there in bright green on the right-hand side is the Greenlandic Norse. And they came in to southern Greenland at the end of the 10th century, but their presence throughout those other regions is definitely felt in the archaeology. And then lastly, I'll also be discussing the Inuit, or sometimes they're called the Thule. And they migrated from northern Alaska into Arctic Canada and Greenland around the 12th or 13th century. And the processes of the interactions between these three people is still debated. But when we want to think about if these groups exchanged with each other or traded with each other, there's effectively three main criteria or three key conditions to consider. First, it's a mutual need. So for two groups to want to exchange something, they both need something that the other has. There also has to be opportunity for that interaction to happen. So by opportunity, I mean they have to live in the same place or broad area at roughly the same time. If they existed in the same area hundreds of years apart, they're probably not going to be trading too often with each other. And lastly, there has to be the capacity. So each group has to have the capacity to actually want to give something in exchange for something else. So these are just three things to keep in mind as I talk about everything today. And I'll revisit it at the very end of my talk. But these are the three key considerations when we're thinking about why these groups might interact, or perhaps why they wouldn't interact. So if we were to go back 20 years, our understanding of Arctic history would be very different from what it is today. First off, we would think that the Inuit migrated into the Eastern Arctic around AD 1000. The dynamics of Dorset Inuit contact are incredibly unclear. Some people argue that there was intermarriage and cultural assimilation or stuff like that. And other people argue that there was absolutely no contact. So very unclear. And also in most articles about Norse contact with these indigenous people, it's more often than not described as brief and around a basic trade axis where the Norse were interested in ivory or furs from Arctic regions, and the indigenous people were, I guess, kind of interested in acquiring metal from the Norse. So it's this basic binary back and forth, which kind of characterized our understanding of Norse interactions with indigenous people at that time, 20 years ago. But now if we fast forward into today, we know that a lot of this is wrong. We know that the Inuit did not migrate into the Eastern Arctic around the 11th century. It was actually a couple hundred years later in the 13th and maybe even 14th century. Dorset Inuit dynamics are still incredibly unclear. A better picture is emerging, but that time frame for the two groups to interact is now shrunk dramatically from almost half a century to perhaps even as little as a century. And lastly, we know that any interactions between the Norse and these indigenous peoples was probably not brief. The Norse existed in Greenland for nearly half a millennium, and their presence in Arctic sites is a lot more pronounced than what we knew basically 20 years ago. So we know that any interaction that was happening was a lot more complex than maybe just a basic back and forth trade. And we still think that the Norse are interested in ivory and furs, but we don't really know the full extent of that. And lastly, sort of my contribution to this topic is that we can say for sure that the indigenous groups didn't necessarily need metal. They had metal and they used metal. And I'll talk a little bit about that and why that, understanding why indigenous groups were using metal actually problematizes our understandings of that basic Norse indigenous interaction network. So this is a map of the Lake Dorset sort of settlement area in the Arctic in what's called the Late Dorset period. So this is kind of the last period of the Dorset before they disappear entirely. So that goes from AD 500 to 1300 or a few decades after that. And Dorset sites are basically spread throughout this region, but there's lots of gaps in the map, so to speak, simply because it's a large area and there's not been a lot of Arctic survey work that's been done to identify new sites in the recent decades. But there's some interesting characteristics about the Lake Dorset that are significant to note when thinking about human interactions. First, we know that they were spread over a huge area, the size of Europe, but they had these incredible trade networks that they had built where they would exchange materials back and forth. We don't really know what those networks looked like or the frequency at that exchange was happening, but we know material was being exchanged. And we also know that ideas were being exchanged. Carved art objects, architectural styles, utilitarian objects become much more homogeneous, so similar in this period than we see in earlier Dorset period. So that's kind of a period of coming together for the Dorset as they actually spread to their maximum extent throughout the Arctic. And lastly, this is also the period where we start to see the first evidence of metal use. And in fact, the Dorset are the first people in the North American Arctic to use metal and to exchange metal widely. At this same time, we of course have the Norse settlements in the southern part of Greenland, going from the late 10th century to at some point in the 15th century. And we also have these early Inuit migration pulses that are coming from Alaska. The earliest sites that date to the 13th and 14th century are actually at high Arctic Greenland. And that's significant because one of the early theories about why Inuit were migrating so quickly and into the Arctic and at such a vast distance was because they were after different sources of metal. Even though this theory has, it's probably not as correct now as it was 20 years ago, it's still a significant thing to note because of where those early sites are. And that's because those early sites are exactly where metal is being found today. So metal and understanding the way it was exchanged in any given or any one of these groups actually helps us understand the whole axis of trade or the whole world of interaction that we see here. So I'll be talking specifically about metal in a late Dorset context to help broaden our understandings of what was going on. So if we look at the metal sources in the Arctic, there's two known sources basically. There's the Cape York meteorite strewn field, which is seen in blue in northern Greenland on this map. And it's basically a huge area where a meteorite crashed down tens of thousands of years ago. And indigenous people can go up there or went up there and collected fragments of that meteorite and shape those into whatever objects they need to use. And some of those fragments are very small and some parts of the Cape York meteorite are huge. And unfortunately, the meteorite has been taken away from northern Greenland and now exists in Copenhagen and New York. But these large fragments are huge. And even if you go up there today, there's still scattered small bits of that meteorite impact throughout the area. The other key source region is where they would have acquired native copper. So this came in the form of float copper, which is effectively, think of it like copper nuggets that melted out of glaciers when they melted or were dug up by glaciers as they pushed through the landscape and are transported through waterways. And the key river for that's called, coincidentally or not coincidentally, the Coppermine River, which is, you can see just the mouth of it on mainland Nunavut there. And also some copper is found on adjacent areas of Victoria Island, which is that big island that's also in that orange area. So these are the two known sources. There might be smaller meteorites that impacted throughout the Canadian Arctic. In fact, we know that there are, and we know that those were exploited, but these are the two ones that were really used to a high degree. Other than that, and the exchange that they might have had with the Norse settlements in southern Greenland, there's no real other sources of metal in the Arctic that would have been accessible to indigenous populations at the time. So if we look at late Dorset metal use, I've plotted on the map, all those yellow dots represents a late Dorset site that has at least one metal object. Some have one or two, some sites have a couple dozen. But if we were to gather up all that material, as I did for my PhD, and we put it all in front of us, it would probably fit inside a shoebox. So even though there might be hundreds of individual objects, they're incredibly small. So this has led a lot of Arctic archaeologists, again, if we go back to the year 2000, a lot believe that even though the Dorset used and exchanged metal widely, it was relatively rare. Some people have argued that it was a lack of preservation in there in Arctic context for specifically metal. As early as the 80s, but that theory was never really tested until I did my own research on the topic. And even though these Dorset sites, these late Dorset sites lack in a lot of individual metal objects, they make up for it in excellent preservation in bone, ivory, and antler. So if you really want to understand metal use, it's hard to understand it just from the perspective of the surviving metal objects. So my key question was, how can I use these organic objects to understand late Dorset metal use? And I specifically looked at organic objects, bone, ivory, and antler, that would have held a metal blade. And the key one that I'll be talking about today are harpoon heads. So for those that don't know, a harpoon head is sort of the distal armature on a harpoon. And the harpoon's basically a spear. And that harpoon head that goes right on the tip of it has a rope tied from that harpoon head that the hunter is holding. So when they thrust it or throw it into an animal, that harpoon head penetrates the animal's skin and detaches from the spear or the harpoon. That way, when the animal tries to flee, they have a secure line on it. This increases the chance of a successful kill and makes a successful kill a lot less effort. So I have an image here. That's a dog. I hope the video is playing, but this shows an Inuk individual who's seal hunting in a breathing hole, and he has a harpoon head. A Dorset harpoon would work very similar. And there he's thrusted it into a seal, and as the seal pulls away, you can see the harpoon head there sticking out of it. He tugs on that rope, and that basically traps the animal there. And the dog is impressed. So that's how a harpoon head works. And these harpoon heads have little distal end blades on them that were made out of stone, but also out of metal. So to examine this, I looked at a bunch of different harpoon heads from across the Arctic. And I'll talk about two types today. The first type is, the first group I used is I basically took all early and middle Dorset, so pre-AD 500 harpoon heads, which you can see on the right-hand side of the screen. And I grouped those together. And then I took another type of harpoon head called a type G, which is an exclusively late Dorset type of harpoon head. And I examined the blade slots on those harpoons. So you can't see it on the two examples on the right, but if we were to rotate them 90 degrees, you would see a slit at the very top of the artifact where that end blade would have sat in. And I've shown an example here on the left. And I took two measurements, which I've circled in red, a midpoint measurement and a distal measurement, just to see how those blade slot sizes change through time in the sense of those two groupings and through space in terms of geographic distribution. So I'll show the data here, and the medial thickness is seen along the x-axis, and the y-axis is the distal thickness. So if you look at it from this perspective, the type G harpoon head, or the post-AD 500 harpoon head are a lot thinner in their blade slot region than older harpoon heads. So this might on its own suggest that the late Dorset were producing thinner blade slots. And generally speaking, a lithic end blade will be thicker than a metal end blade, or can be thicker than a metal end blade. So that means if you have a very thin slot, it can only fit a very thin end blade. So it's interesting to see the differences here. And just to note, these two harpoon head types or groups would have been used for the same purpose, which is hunting seals. So if we compare that with the thicknesses, corresponding thicknesses on end blades, and these are some examples here. The ones on the left are made out of stone and the one on the right is made out of metal. And if we compare these to the blade slots, we can actually see the patterns even stronger. And I'm just going to show the lithic end blades here in black. So we can see that there's all this scatter of black end blades, and there's over 1,000 individual end blades here. And we can see that these earlier harpoon heads correspond quite well with the distribution of those lithic end blades. But there's a good population, about 60%, or just over 60% of the later harpoon heads, the late Dorset harpoon heads, that even if you took the thinnest lithic end blade in the whole Arctic and tried to fit it into that harpoon head, it wouldn't work. So this in itself shows that probably, at least from a late Dorset perspective, at least 60-some% of their harpoon heads could not have held a stone end blade. So that's a significant proportion, because it's even more impressive because harpoon heads themselves, being thrown or thrusted into an animal, are at a very high risk of being lost. So you wouldn't put your most precious thing at the literal tip of a spear to then be thrown away. So I think this shows that metal was actually a lot more common in late Dorset life than the existing metal assemblage shows. And we can also see this converging together by looking at harpoon heads in another way. So if we separate, again, these harpoon heads into three broad types: the really early type at the top, the late Dorset type at the bottom, and then also a type of harpoon head that's used throughout the Dorset period. So from 500 BC all the way up to the late Dorset and through it. And we look at how those end blades were attached to these harpoon heads, the same pattern emerges. The vast majority use what's called wedge hafting. So wedge hafting is effectively the pressure of the harpoon head blade slot pincing on that end blade to hold it in place. And this is the only type of hafting that we see in those early harpoon heads, and it's the most common type of hafting used in the Dorset parallel harpoon heads, which are larger and thicker harpoon heads. But when we look at type G specifically, we see two different types of hafting. The most common type is they use what's effectively a rivet hole or a securing hole. So you can see here on the examples along the top left that they have little perforations along the distal tip, right where that blade slot or that end blade would have fitted in. And why this is revealing about the material type that they would have used is because a stone end blade, especially those produced by the Dorset people, were generally made out of chipstone materials. So that's chert, flint, quartzite. And those types of materials are almost impossible to perforate or to put a perforation through it without effectively destroying it. And it certainly would have been impossible before the advent of an electric drill. So those types of materials could not have been hafted in these harpoon heads and still have been functional, functioning with that securing hole or rivet hole. So that means a metal end blade, which can be perforated using hand tools, would have fit into that. So over 45% of type G harpoon heads had that perforation. And the only examples found on non-type G are found on Dorset parallel harpoon heads. And the specific examples, which you can see on the bottom there, those are found in late Dorset sites. So no early or middle Dorset harpoon heads in the whole data set, which was hundreds of harpoon heads, had any kind of alternative hafting technique except those in the late Dorset period. And the other type of hafting is that was identified is a lashing groove. And that's effectively, you can see along the distal tip, it's the same set of harpoon heads on the right-hand side. The top have no annotations and the bottom show the annotations of where those lashing grooves would have been or are. And the lashing groove is effectively a sinew line that would have been tied around the tip of the harpoon head to hold in the end blade. Again, if we think about thin metal end blades and potentially wedge hafting itself not being sufficient enough on its own to hold that end blade in place, alternative methods such as lashing, using lashing or sinew lashings would make sense. So both these types, which again are only seen on late Dorset harpoon heads, again speak to the fact that they were just using more metal, right? And I'll just speak briefly, but also if we observe these harpoon heads under a microscope, we can see traces of iron oxide, so rust, that would have been deposited as they were holding an iron end blade. And these are found only on a small portion, about 30% of the harpoon heads that I observed. But what's more important is that no iron oxide is identified on early harpoon heads. So this shows that both the timing of when metal was starting to be used around 8500 and was used throughout the late Dorset period all the way up to the 14th century, and also the extent of it. Both the blade slot and the hafting data show that they were using metal at least as frequently as stone, and probably more frequently than stone for certain activities. Right, that's just the statistics there. There we go. Sorry. If we look at where the sites I sampled are, all those red dots on the map are those sites. Not all those sites have late Dorset harpoon heads, but most do. So you can see that they're not clustered around these sources. Remember, look at the scale bar at the bottom. We're talking thousands of kilometers potentially away from these sources, and even more if you consider actual travel routes, which don't go in a straight line. So some of these areas were thousands of kilometers away from, or over 1,000 kilometers away from potential sources, but still had evidence of metal use. So it's showing us both that metal was being used widely and intensively in this time period, and only used in this time period as widely as we're seeing than compared to other earlier time periods. So the other problem that we also have to face is understanding the timing of these groups. And one major challenge in Arctic sites is the chronology. The chronological data is not great. And that's because a marine reservoir effect impacts a lot of the materials that you would try and date. So a lot of materials in Arctic sites that can be dated are derived from the marine environment, which skews the date older. So a lot of the earlier dates that come from work decades ago almost can't be used anymore. But Max Friesen has modeled specifically secure terrestrial mammal bone dates in the work he's done in Victoria Island. And he's actually modeled late Dorset presence that goes all the way up into the middle of the 14th century. So pretty much that's about 50 years later than what has traditionally been thought, but the data is only from this one portion of the Arctic. And other work like that is ongoing and in the other parts of the Arctic, like the work I'm doing. I've modeled early Inuit dates, because if we know that the Dorset were there up until the middle of the 14th century, so that's a century before the Norse abandoned their settlements and around this the same time that the Western settlement was abandoned. What about the Inuit? Like I said, a lot of early work suggested a date of the early 11th century for their first migration, but later work has thought that it happened maybe in the 12th or 13th century. So I took all early Inuit sites that have dates from terrestrial mammal bone, and I've modeled them using Bayesian statistical analysis, which you can see the output here. And what I found was that the sites most, in terms of the probability, most likely represent a migration that started in the late 12th century, and more likely in the first half of the 13th century. So that means if we're thinking about opportunity to interact, the opportunity for the Inuit to interact with the Dorset is a lot more limited than their potential opportunity to interact with the Norse. And again, the Dorset's opportunity to interact with the Norse is a lot more robust potentially than the opportunity for them to interact with the Inuit. So this is what we know. We know that the Inuit migration happened much later than traditionally thought, probably in the first half of the 13th century. We also know that the Dorset persisted well into the 14th century and probably even a bit later in certain areas. And we know from work that's been done from UK-based researchers that later Norse Greenland walrus exports come from North American waters. So that means, was it possible that they were capturing these walrus themselves? Yes, but it's also equally likely that if any interaction did happen, that they could have been acquiring them from indigenous people. And we both know that the Dorset and Inuit were expert walrus hunters. And lastly, we know that the Dorset and Inuit were very familiar with metal. They had well-established exchange networks and knew where to get metal. And these exchange networks went across thousands of kilometers, which is comparable to the distance of the Norse settlements in Greenland and Scandinavia. So it's the same almost scale of trade networks on the other half of the Atlantic. So where do we go from here? We know that there's a capacity and opportunity for interactions between these three groups. We knew that the indigenous people could supply walrus ivory, and we know that potentially the Norse could supply metal. But was there a need for that trade or interaction to occur? And that's the big question now, because we know that the Dorset had access to metal sources. So what were they getting in return? And likewise, we know that the Inuit have access to metal. And what were they potentially getting in return? So these questions are a lot more nuanced now than what we, excuse me, than what we thought only a couple decades ago. And lastly, most importantly, the Arctic archaeological record needs more data collection. It's one of the few areas that any archaeologist would ever say this. And there's a lot to be learned in museum-based collections, but one of the big limitations for an area the size of Europe is that we simply do not have a robust enough sample size from across that region to really understand what was going on at this time and the variability of what was going on through time and through space. Okay, thank you. That's my talk.
Thank you very much, Patrick. That was fascinating. That was great. Thank you very much.
Thanks.
I'm delighted to see the progression from your earlier work, and it was really interesting to see the recalibrations of the using the Bayesian statistics for the dates, because that will give obviously quite good refinement. So yeah, so that's excellent. We have one question which has been requested by a couple of people here. And I'll just read that to you. It says that, are there any clues to the demise of the Dorset people within First Nation folklore? So I don't know whether you can elaborate on that topic. That's an enormous topic in itself, but any thoughts on that?
Yeah, I mean, it's not my area of expertise. You know, the best people that have that knowledge are the indigenous people themselves, because we definitely know that oral histories have continue to persist in northern regions really strongly. But from my knowledge of it, there is some Inuit oral histories do talk about a people that existed in the Arctic before the Inuit that are known as the Tunit. And they talk about their interactions with the Tunit in different ways. It starts out friendly and happy, and oh, we're just living beside each other. And they describe the Tunit as baby talk. They're not really smart. They're really strong, but they're not really smart. And they, you know, they say really interesting things like the Tunit only know one song. So anytime they see the Tunet, they're only singing the same song over and over again. And that's interesting because those oral histories exist throughout the Canadian Arctic, but they also exist in southern Greenland. And in southern Greenland, we know 100% that the Dorset were never in southern Greenland at the same time as the Inuit. So it's an interesting aspect of where these oral histories are coming from, how that social memory kind of persists and how it's built in the first place. So we do know a little bit about that. And just the second part of the question is then, of course, there are oral histories that say, oh, we drove the Tunet out, we scared them away, or the Tunet, in some cases, like in around Pond Inlet, an oral history there says that the Tunet prepared the land for the Inuit, and then when the Inuit arrived, they said, okay, take over for us, we're going somewhere else. So there is, there's not a lot of evidence for that, but there's also not been a lot of modern research that has worked with Indigenous communities to figure out, you know, what those oral histories are and the scope of it. So, yeah.
Thanks very much. Thank you. Now we've got 3 more questions. So I guess we need a kind of short and snappy answers.
Yeah.
I'm sure people can follow them up by making direct contact with you if you're okay with that. But
yeah, sure.
So Deborah has asked and said, you've provided evidence for a significant range of sites for metal objects, metal sources, trade networks. Do you have any evidence for metalworking sites?
There aren't specific metalworking sites. We do have debitage in that metal collection. There's debitage and there's different stages of production that we can see, but almost all metalworking was cold hammered. So heat was not used or used only sparingly in forming those tools. So we don't have a lot of evidence of that, but there is evidence of it.
Okay. The next question from Linda is, were there other kinds of metal objects found? And is there evidence that the Norse had metal that came from the North American area?
So the types of metal objects that are found in Dorset collections, they're almost all utilitarian. So they're knife blades, harpoon end blades, little bits for engraving, things like that. There is one example of an amulet that's found in around the Hudson Bay, the east coast of the Hudson Bay. But other than that, that's pretty much it. And in terms of evidence in Norse sites for North American metal, there is some evidence of that, but the recent reanalysis has shown that some of those objects that were thought to originally be Cape York metal are actually not. So it's a challenging question, no answer yet.
Okay, so a couple of questions which are quite related really, and one is that is the metalwork found just copper or iron, or were alloys used such as pewter? And linking with that, were there other types of metals in use, or was it just about survival? So that would take in silver and gold.
Yeah, it was only native copper, meteoric iron, and any there are some alloys, bronze objects that are seen, but those are interpreted as being evidence of exchange with the Norse. But there's no indigenous metallurgy like we see in Europe, making alloys and that kind of thing. There's no evidence of that. And there's no evidence of gold or silver or any precious metals in this part of the world.
Right. Okay. And then this has to be the last one, I'm afraid, because we're now out of time, really. This is from Andy Dugmore. Knowing the later impacts of Western diseases on the Inuit, is there any evidence of disease entering the Arctic from the east? Can you answer that? I don't know whether you can answer that.
Well, yeah. I mean, that's a really interesting question, and I think I think there's so much scope there for more work to be done, but I think there's some indications that there was some disease transmitted from Norse to Inuit and Dorset people, but a challenge in this is that there's not a lot of human remains in the Arctic, and certainly those that do exist, they're not, it's not currently appropriate to be doing analyses on those just by the way they were collected and all that. So that's definitely a question, though, that would be awesome to think about, but there's not a lot of evidence, I don't think, right now.
Okay, thank you for that. And just one last comment, which I'll just answer if you don't mind, Patrick.
Yeah.
It comes from Will Routledge, who's basically saying he believes there was evidence for bog iron smelting at Lancer Meadows. Yes, indeed there was. And of course, there's a great big discussion around the Point Rose site in Newfoundland as well in relation to bog iron, but that's an absolutely not proven argument. So there is bog iron smelting at Lancer Meadows, but not at Point Rose as far as we can see. So I think with that, if that's okay, I think we should just draw a line under your presentation, Patrick. Thank you very much for that. Most interesting, and we look forward to seeing the results that as you present them. Thank you so much.